Hello. Okay, so let's get into how this Terraform and Azure DevOps works in my environment. So first of all, let's show you what it actually does to show you what the end result should look like at the end. So if I go into my Azure environment here, as you can see, I've got no resources at all deployed in here currently. The only thing that is deployed are some management groups and some policy definitions. And as you can see, they're all built out here and look very similar to enterprise scale, but we're not covering that today on this video. In the subscriptions, you can see I've got 3 subscriptions, and if I go into all resources again, you'll see that there's nothing deployed in here. If I then go into Azure DevOps, and you'll see I've got 1 project in here, enterprise scale Terraform community, but if I then look into the repositories and my files, you'll see that I've got a Terraform folder in here, and I've got all of my management groups defined in this file here, and that's what's deploying everything into my environment. As you can see, I've got a Terraform plan build pipeline, and I've also got a release pipeline here as well to actually deploy the infrastructure into Azure. But instead of just showing you this, and we'll dive into how this is created later, let me show you first of all what it looks like from an end user experience if I want to deploy something into my Azure environment. So if I dive into VS Code, you'll see I've got the same repository cloned here locally on my laptop. And let's just create a new Terraform file inside this Terraform directory. So let's just call it demo.tf. And inside here, let's just go and create a resource group. So let me go and copy the code for a resource group in true Blue Peter fashion. Here's one I had earlier. And we'll just remove some properties off of here that aren't going to be required. You'll notice that I'm using the provider and the alias functionality inside of Terraform here, because I want to deploy this to a specific subscription, my connectivity subscription. And if you look inside my providers file, I have this subscription here defined here, and with the alias of connectivity, so it should appear in my connectivity subscription. Cool. All right, let's just create a resource group here called RSG V1 001. It's going to go into North Europe. So let's save that file. Now, actually, before we save that file, a really important thing to note is that we're currently in the master branch here on my repository. And the way that I've got this configured is that you can't actually commit code directly to the master branch. It has to go through a pull request process. So what we first of all need to do is create another branch, put our code into there, and then push that branch up to our Azure DevOps project and inside the repo where this lives. So let's create a new branch, and let's call this demo1, and that's created that branch there. And now, as you can see down here, VS Code has changed into this branch, but if we wanted to select into that, you can click on it, select demo1 that you've just created. Now we can save that file into there. And then if we could see over on the left hand side, the Git extension is now reporting there's 1 file to change, and it's our demo.tf file. So let's go and add that and stage the change, and let's just say create demo resource group. And if we click this button here, that will do a git commit into our branch. And then right down the very bottom now, we can click on this little cloud icon with an upwards arrow that's going to push this branch up to the remote repository in Azure DevOps. So let's push that. And now that's completed, if we go back into Azure DevOps and back into our files on repos, you'll see that it says you've updated demo1 branch just now. And if we actually click branches here on the left, you'll see that we've got a demo1 branch here that's just been added just now by me. So if that's what we need to do is create a pull request to put this code back into our master branch, which will then kick off all of our pipelines and all those requests. So as you can see, we can click create pull request here. And what we're saying here is that the demo1 branch needs to be pulled into the master branch. And this is the pull request template, so we can fill in here. So we can call this demo1 PR create resource group, and we can put the same in the description, but obviously you can fill this out in your environment whatever way you want. And as you can see here, I don't need to specify any of this. I've got some branch policies that we'll dive into later that put all these options into place. But if you want to add some reviewers, whether they be required or optional, you can add those in here and that will work just fine. I can also link this to a work item, but I haven't got that configured in this environment. And I'm also just going to add the tag that I'm using of demo just so that I can keep track of these. You can see the files that are going to be included. So it's that demo TF file, and it's the resource group that we said is going to be created. And you can see the one commit that we put into that as well from VS Code. So if I now hit create, that's going to create that pull request. And as you can see, a few things have happened here in this pull request. So first of all, you can see that it says Jack Tracy must approve, even though I didn't add myself as a required approver. My branch policy automatically added me as a required reviewer, and we'll dive into how that's configured later. And you'll also see that there's a status check running. So I've got another build pipeline that runs that effectively does a Terraform validate and a Terraform plan just to make sure that the code is all valid and syntactically correct. And it'll also give us a bit of an overview of what it's going to deploy, so that whoever's reviewing this pull request, obviously it wouldn't be me in an ideal world, I wouldn't approve my own homework, but they can review what's gone on and what it's going to deploy, and then choose whether to allow that or not. So if we go into the required check succeeded here, and we click view check, and you'll see that this Terraform status check build pipeline completed successfully. So if I click into that, let's go and have a little look at what that did. So it kicked off just now, it took 29 seconds. And if I dive into the status check job here, and as you can see, it did a load of things. So it downloaded some secrets from a key vault, it checked out the repository, installed Terraform, did a Terraform init and connected to the remote state, which is also stored in an Azure storage account. And then it did a Terraform validate, and we got a success there, which is all good. It also did a Terraform plan. Now, as you can see, all my management groups from modules and policies that are deployed. But if we scroll right to the bottom, we've got down here one to add, and it is that resource group that we added earlier. So it looks good. It hasn't deployed this. This is just Terraform plan phase, and as you can see, the job stopped. But that's reported back into our pipeline, into our pull request, that everything's good. And now the person who's reviewing that can make an informed decision as whether to approve that pull request or not. So let's go back into our pull requests. And as you can see, it's sitting here still waiting, and we can put a note in here that says, yeah, it looks good to me. And we can add that as a comment, and we can mark that as resolved as well, because that's a good thing to do on your pull requests. And we can now click approve, because we're happy with what it's doing. You can also click in here and from the pull request and see what's being changed and how many commits have happened. And that's it. So if we now click approve, brilliant, that's now approved. And we can now complete the pull request, which will actually push this code from the demo 1 branch back into the master branch, and then the build pipelines and the release pipelines will all kick off to actually deploy this into Azure. Because if we look in Azure right now, and we go into the resource groups and hit refresh, you'll see there's still nothing in my Azure environment here. Okay, fine. So we're going to complete this merge for this pull request. So there's no associated work items, so we don't need to tick that. And I'm going to customize the message if I wanted to for the commit message, but that looks pretty uniform to me. And we're going to say delete the demo 1 branch after merging as well. So let's go and complete that merge. Okay, and we can see up here it's merging that pull request. And great, that's completed. This pull request is now show as completed. And if we now go back into our repository, and we're on the master branch here, you can see that just now our pull request commit has gone in here. So the merge of the code from our demo branch into the main branch has happened. And we can now see we've got this demo TF file here on the left, and also it's just listed here, and we can see it says just now, and it's come from the commit of our demo. So that's great. And actually, if we go onto that file, you'll see that it's exactly what we typed in VS Code. And if we actually go back to the main repository, you'll see that there's this in progress icon up here. Now remember I showed you the build pipeline earlier of Terraform plan. Well, actually this has automatically been triggered by new code being committed into the master branch, but we've protected that from being done directly, and it has to be done via a pull request with branch policies, and we'll dive into that later. So if I click on this in progress here, you'll see that the Terraform plan pipeline is running. So let's go and check out what's going on in there. Cool, so we can see this is actually just completed. It looks like it's just finishing up, but if we go into the jobs here, you'll see Terraform plan, and again it looks very similar to that status check that I had. The only difference here is that once it completes the Terraform initialization, the validate and the plan phase, and again, if we went into the plan, we'd see exactly the same thing going on here. So one resource to add, and it's just that resource group. All we do then is archive the resource. We basically do a Terraform plan to a file. So as you can see here, it says Terraform plan and out TF plan. So it's going to put it out to a file named TF plan. It then archives that up, so puts it in a zip folder from my Terraform directory, and it'll publish that zip folder to a pipeline artifact, and that artifact will then be used further on in the process. So if we go back to the pipeline, we can see that Terraform plan for the commit that we've just made has been complete. And actually, if we now go into our releases, and I will have actually got an email about this because I've got email alerts set up here saying that actually, as you can see, I'm pending approval for the Terraform apply stage. So this is sitting here. There's still no resource group been deployed to Azure. So even though we've done one approval and we've let it now run, and and we've approved that pull request, it's still not deployed because I've configured my Azure DevOps pipelines in such a way that actually you sort of get two approval chances. So if we click into this release here that's pending, as you can see, this has been triggered from an artifact from the build pipeline that's just run. And if we clicked on that, it would take us back into that build pipeline so we could see its history. And we now can see that it's sitting here at the pending approval for me to say, let this go and approve and run in my Azure environment so that it'll actually deploy this resource group. So if I was to wanted to see what had happened before and what had triggered this and what's going to be deployed, I could click back onto here. And I could go, actually, let's have a look into the pipeline run that happened, and it'll open up the build pipeline again, and I can click back into the Terraform plan, build out job, go and have a look at the bottom of the TF plan job stage, and as you can see, it's just that resource group to add. So I'm fairly happy that it's doing what I want it to do and nothing else. So I can go back into here and click on approve. I can go, yeah, all okay. And we can get that to approve. Now I could select this box here and defer it to deploy at a different date and time if I didn't want it to happen now. And that's quite a nice reason why I've got this second approval here before anything's deployed, because you might want to say, yes, I approve this during the day, but it can happen tonight when we've got a change window approved or something like that. So I'm going to leave that unchecked now because we want it to happen right this second. And if I hit approve, that's now going to kick off my Terraform apply release pipeline. So if we click on the logs of this, you'll see we're just waiting for that to be queued, and it looks like it's found a hosted build agent, and off it goes. So this is now going to run. So it's downloaded the secrets again. We're downloading that artifact from the Terraform plan build job that we had. It's extracted those, downloaded some Key Vault secrets. Now we've installed Terraform, done a Terraform init to the remote backend, and now it's actually doing a Terraform apply based on that plan file, and that's it. It's all done very quick. If we just drill into that Terraform apply step and we look at the Terraform apply step in the job, you'll see that apply completed, one resource has been added and nothing's been changed or destroyed. And if we look at the Terraform apply command here that's used, we're saying Terraform apply auto approve and input false, so we don't get any prompts at the Terraform apply stage, because obviously this is running in a hosted build agent, which we can't interactively interact with, and we can't put any prompts in if it asks for yes or if it asks for a variable input. So we need to put those options in to ensure that it just runs straight through without any prompts. And where we say TF plan here, that's using the TF plan file from that build stage that we created earlier. So if we now go back into the Azure portal and I hit refresh, we've now got our resource group, and with any luck we can see it's into my connectivity subscription as well, so it's gone where we needed it, and it's been deployed into North Europe as well. So all from creating a pull request and writing this piece of Terraform code, going through that process inside of Azure DevOps and sort of our CI/CD process, we've now got that deployed, and I actually didn't touch the Azure portal at all. So that's what it will do, and that's what the end result should look like. Let's dive into how we actually make that happen. Okay, so our first step is creating an Azure DevOps project, maybe an organization as well if you haven't created one of those. If you haven't created an Azure DevOps organization or haven't got access to one, you can create one for free by just going to dev.azure.com and creating an account there, or logging in with any valid Microsoft account, and create your own organization from there. Completely free to do for up to 5 users. I won't go into the billing details here, but for small demos and lab environments, for less than 5 users, completely free to use. So go to dev.azure.com and create yourself an account, or log in if you've already got one. If you've already created yourself an organization, like you can see down the left-hand side here, mine's called J Tracy Microsoft, or MSFT. And I've got one project already within here, and this is the one that we dived into in the demo just a second ago. So we need to create a new project. So let's click New Project in the top right here, and let's just call this TF Azure DevOps Demo. And we can make this private so that it's only accessible to me and the people I give access to, and I can hit Create. By creating this, it'll automatically create a Git repository or an Azure repo within this project automatically. So if we now go over to the left and click on repos, you'll see that this is an empty repo, right? So the repo is already created here, TF Azdo demo. What we're going to do is clone this into VS Code. So if you've got VS Code installed, which I'm assuming most of you will do by now, you can automatically clone this into here by clicking the buttons up here. But one important step that I think is really important and really nice of the Azure DevOps repos option here is we can initialize this with an initial README or a git ignore file. So we don't want the README file, that's fine, we don't need that, but we do want this git ignore file. And actually there's a pre-built one for Terraform. So if you look for Terraform in this search box, you can automatically add a .git ignore file for Terraform. Now the git ignore file basically tells Git what files not to upload to the central repository. And in Terraform, that is very obviously don't upload the state file, don't upload any TFRs files, all of those sort of things. So it'll automatically add a pre-configured .git ignore file, so you can be safe in the knowledge that you won't ever be able to commit any of those to the central repository. So don't click any of these options up here. Come down to the bottom section here, select Terraform in the git ignore section and hit initialize. And as you can see, this repo now has one file called .git ignore, and if we browse into that file, as you can see, it's just got all of the exclusions in here. So exclude the local Terraform directories, exclude the TF state files, and exclude the TFRs files. All really important steps to make sure you've got done to make sure that you don't expose any secrets into a centralized repository and it's all shown in plain text. So if we go back to the repository, or we can click on the repository up here, or we can go back to repos and click files, we can now clone this repository onto our local machine to make it easy for us to edit and upload files. So if we click clone, and I'm just going to copy this link here, and then if I go into VS Code and I hit Control-Shift-P, I'll get the prompt pop up, and if I type git clone, you'll see that there's one already in here, and I can select git clone, and it's now saying provide the URL, which we've now got on our clipboard from what we've just pasted from Azure DevOps, and I can then hit enter. Now it's going to ask me where do I want to put this repository. So I've got a place on my machine where I store all my repositories, so I'm just going to put it in the right place here. I'll say yep, you can go there. And now it's cloning that repository. Now, if it's the first time you've done it, it might ask you to log in and authenticate against that repository, but because I've already done it, mine's taken me straight through. So now that's finished cloning, I can say, yeah, open that. And now it's going to change VS Code to that directory that we selected just a second ago. And as you can see, I've got that one file, that .git ignore file, which is exactly the same as what we had in Azure DevOps. If I go back here, it's exactly the same file, and that's what it is. So we've now got the local folder on my machine, and if you right click here and say reveal in File Explorer, so if inside my machine, if I browse to this C Git repos folder, and then I've got one for all my Azure DevOps J Tracy MSFT projects, and this is the TF as Azure DevOps demo project I created, and this is the repo. All the files in the repo are stored in here as we selected when we did that git clone process. So that's everything I want to show in this step of the video. We've got our repository cloned and synchronized with the Azure DevOps project and the new repo that's been created inside that project. In the next step, we'll dive into how we need to create a few prerequisites to store things like the Terraform remote state, some key vaults to store some secrets for Terraform, a service principal that Azure DevOps can use to log in and access that key vault and access our Azure environments, and also creating a variable group inside Azure DevOps. So I'll catch you in the next step. Okay, so before we can really get into configuring Azure DevOps and Terraform and linking them all together, we need to set up sort of some prerequisites for Terraform. Now, because we're using it in a DevOps fashion and we're not running it all locally from our machine, we need that state file to be stored in a remote backend, as it's referred to inside of Terraform. So what we're going to do is configure that to be an Azure storage account, and that can just be a blob storage account. So pretty low cost. Obviously the state file is pretty small, but obviously it will grow however big your deployment with Terraform gets. But obviously by putting it in Azure storage account, we can control it without the storage control access keys. We know that it's encrypted by default using the Azure storage encryption services. So it's a good place to be storing it, and obviously it means that the Azure DevOps pipeline we can configure to get access to it, and we'll walk through all those steps. But first of all, we need to create a couple of manual things. Now, you may be thinking, why aren't we creating this with Terraform? That's a great question. We absolutely could do this, but it is very much a one-time task. So we need to create a storage account, we're going to create a key vault, we're going to create a service principal. They're really the only three things that we need. Now, we absolutely could create them with a Terraform deployment or an ARM template, but as they're very, very basic resources to create, and we're only creating them the once, creating them manually in a portal is absolutely fine. So first of all, let's just create a resource group, and I'm going to put this in my management subscription that I've got here, and I'm just going to call this TF ASDO demo RSG, so that we've got all of our things in that resource group, and I'll put this in North Europe. I'm not going to put any tags on it. Yes, put what you like in the comments. Yeah, I know that's bad practice. And we're just going to create that resource group. Fantastic. All right, that resource group's created. And then we want to create a storage account. So we can look for storage account. Great, we will have one of those, please. And we just call this TF ASDO demo storage account. Storage 001. We'll pop that in North Europe as well, and we can leave it as V2. We can set it to LRS because we don't need anything higher than that. We can leave the networking as public. We won't dive into how we configure this with private endpoints or service endpoints. It's not something that's very easy to do. We're using the hosted agents in Azure DevOps anyway. Leave all these options there. We're going to say turn on soft delete for blobs, and keep that for 7 days. So this is quite handy in case your state file becomes corrupted. We've got a way of getting it back, and we're also going to turn on versioning for blobs for that case as well. Should anyway delete the state file, we can get it back for 7 days, and also every time it changes, we're going to get a version of it so we can roll it back as well. So this is a really new feature for blob versioning, but it's great to take advantage of for this scenario as well. Go to the advanced tab. We're going to make sure that secure transfer required is enabled. We're going to make sure that TLS version is 1.2. We're going to leave disable allow public blob access, so nobody can get into this by just guessing the URL. And we're going to leave the access tier as hot by default. And that's all we need to configure here. Again, we're not going to add any tags. We'll go to the review and create page and hit create. Great. All right, while that storage account is going to create, that shouldn't take too long. If we dive back into our resource group, we can create a key vault as well, and this we're going to use to store all of our secrets that we want our DevOps pipeline to know about. So things like the storage account access key, our service principal login details, all of those things. So if we create a key vault and pop it into the same resource group, so in that same resource group, and we'll just call this TF ASDO demo key vault 001 North Europe again. And we'll leave that on the standard pricing tier, and then we're going to enable purge protection, and we're going to say retain the deleted vault for 90 days, and soft delete is automatically enabled now for us. On the access policy, it's going to add myself, so that I can access and manage these keys in here. We will need to come and amend the access policies later to make sure that the service principal for Azure DevOps can actually read the keys, but we'll come back to that. We again leave the it to be publicly accessible from everywhere, because Azure DevOps is running the hosted agents. We know where it's we don't know where it's going to be coming from all the time. We don't need to add any tags for this demo, and again we can hit create and pop that key vault in as well. So that's creating, and let's go back to our resource groups, because I'm pretty sure our storage account will be done, which it is. Here's our storage account. So in our storage account we need to add a container. And let's just add a container here. So we can call this Terraform -state, because that's what it's going to store. Make sure I've spelled that correctly. And hit create. Okay, so we've got a container now in our storage account called Terraform state, and we don't need to do anything there. And one thing we now do need to do inside of our storage account is just take note of the access keys. So I'm going to just open up a good old notepad window. We've got that here. I'm just going to say these are the storage keys, and key 1 and key 2. And the reason I'm taking these down for the moment is we need to put these inside our key vault. Yes, I could use manage storage accounts in terms of the key vault, but for this demo I want to show you sort of the bare bones, and obviously you can add on and change this slightly, but if you understand the concepts you can do what you like to change these steps out as you please. So let's get the access keys. Now obviously they're going to be blurred out for you, but let me just copy those, and I'll blur these out in the video as well, so you can't get into my storage accounts. Right, okay, so we've got those copied to our notepad file here, and we're not going to save this notepad file, so be careful, because we don't want to store this anyway. We want to delete this once we're finished with it. It's just a temporary storage location so that we can put these into our key vault. Alright, so let's go back and find out that said key vault. One thing is also worth taking down is the storage account name as well, because we're going to need that later. So we're just going to take that down and pop that there. And the resource group that it also lives in is also something we're going to need later as well. So we'll just take down the resource group name. Alright, so let's go into our resource group and hit refresh, because our key vault should be there now, and it is. Fantastic. And let's create a couple of secrets. Now these secrets are going to be the keys for our storage account that we just created. So we're going to give these a name, and I generally give them the same name as the storage account, and then append them with either key 1 or key 2. So I'll do that now. We should set some expiration dates and some activation dates, but for the ease of this demo I won't, and we'll make sure that it's set to enabled, and hit create. And we're going to do exactly the same for the second key as well in here. So let's go and get the name again and put key 2, and go back to my temporary notepad and get the keys. Make sure we're not copying any spaces or anything like that in, because that will catch us out later, and hit create. Perfect. All right, those keys are in the key vault from the storage account. And what we now need to do is just dive back into Azure DevOps. So let me find that. So we're back inside of our TF Azdo demo project. And what we actually need to do is create a service connection from here, which will actually just create a service principal for us. So what we need to do is go into project settings, and if you didn't see that, I'll just dive back into the project and show you how to do that. So you go right to the bottom left hand corner next to the cog, and you've got project settings, and then in the new windows that appear on the left hand side you've got an option under pipelines called service connections, and it says, look, you haven't got any, but do you want to create one? Yes, we do. So let's create a service connection. And as you can see, we've got one in here for Azure Resource Manager, because that's what we're ultimately connecting to at the back end. We're connected to ARM. So we can hit next, and we can say this is automatic. Now this can actually load the subscriptions that this account has got access to. So I don't actually have access to those subscriptions that I've just been creating from the account that I've logged in with my Azure DevOps. Now, if you've done this, you can follow this process through and create it from here, and it'll be nice and easy, but I don't have that privilege. So we're going to go back and say, actually, we're going to do this manually. So we're going to say it's the Azure public cloud, and it's going to have permissions over a subscription. And let's get the subscription ID. So let me dive back into my Azure portal and go onto my management subscription and get the managed subscription ID. And let's get its name. And then I'm actually going to need to pass in some details into here. So I'm going to need to pass in the service principal ID, the service principal key, the tenant ID, and click verify. Now, it won't actually create the service principal for me, so we're going to have to go and do that in the Azure portal manually. So let's go back into Azure, and let's go to Azure Active Directory. And let's go to App Registrations and click New Registration. And let's just call this TF Azure Demo SPN, and we can leave it with the first option here, and we don't have to put in any URLs. That's fine because it's all good. We can hit register, and that's it. So we need to copy the client ID, and again I'm going to use my trusty notepad to store all of these details temporarily, so we can call this SPN details. So this is the client ID. We need to copy the tenant ID. So tenant ID, copy the object ID, and we need to also get a secret for it. So to do that, click certificates and secrets, and then under secrets you can hit new client secret. Choose when you want this to expire. Now obviously, this will fall into your secret rotation policies and stuff like that. So the shorter the better. And I'm just going to call this secret 1 for the demo purpose. Now when you hit add here, it's very important you don't click away from this page because the secret is only shown once. So if I click add, you'll see that this value is blurred out for you, but I'm going to click copy to clipboard and the secret is actually there. And I'll just put this here, and again this will be blurred out for you, but make sure you copy that secret out there, because once you click away from this page, the secret will still be valid, but you will never be able to retrieve it again. You'll have to create another secret. So we've got all of our details now for our SPN, so let's go and fill in the Azure DevOps wizard. So it's asking for the service principal ID, and I'm pretty sure that that is going to be our client ID. So let's grab that and pop that in there. The key, which is also the secret, so let's get that and pop that in there. The tenant ID, which is our Azure Directory tenant ID, which we copied out as well, and that's it. And we should be able to say add in a service connection name, so we can call this TF Azure. What do we actually call the service principal? Let's use the same name because then it makes everything match up. If I could copy that, there we go. And we could put a description if I wanted to. And that's about it, I think. Let's hit verify and make sure it works. Oh, and it didn't. So it says, right, so it doesn't have permissions over the subscription. Very good point. That's why the verify button is very important. We all make mistakes. So we've created our service principal, but we actually haven't given it any permissions over anything in Azure. So actually, let's go to our subscriptions. Let's go onto our management subscription. And let's go into access control and IAM. Go into role assignments, and as you'll see, my other SPN for Terraform is in here, and it's actually inherited from my management group structure, another one that I've set up in the past, but the one that we've just created hasn't got any permissions. So let's go and add a role assignment in here, and let's make it a owner, because you might want it to create RBAC assignments on the subscription, so you're going to need it to be an owner. And let's search for its name. So let's go for TF Azure and see what pops up, and there it is. And click add and click save, and then that is going to give it that RBAC permission. Now that should be fairly quick, however it can take up sort of 10-15 minutes to apply. So let's go back into the portal and click verify, And great, that's already taken effect. So it now is confirmed it's got permissions over the subscription that we specified up here. That's all looking good. And we're going to say all of our pipelines can access this permission as well. So let's verify and save. And great, that is now created. So we've got that service principal here, and you can see it's been created, and we can click on manage service principal and it will take us to where that is. But all good, we don't need to do anything, that's there. Now the final piece we need to do is put all of those service principal details into our storage account as well. Sorry, not into our storage account, into our Key Vault as well. So let's go and do that. So it's back into the Azure portal, back into our resource group that we created, find our Key Vault, and we need to create some secrets. So we're going to call it the name of the service principal again, just to keep everything uniform. And I would recommend keeping everything lowercase, especially if we're planning to use Linux build agents, just because case sensitivity will come into play. So we're going to need to add that there and copy that to our clipboard, because we're going to need that more than once in a second. First one will be the client ID, so -client -ID. And let's go and get the client ID here. And again, make sure we're not copying any secrets or not copying any spaces or white space into here. And add that. And we're going to need to do the same again. So let's go back into here, get our prefix for the secret. And this one will be the tenant ID. Maybe wondering why I put all of these details into the Key Vault. It's just a habit. I think it's good that everything's sort of contained within the Key Vault if it's going to be queried, because then we know it's all being accessed securely. It's all being accessed over sort of TLS when those keys are being retrieved. But you could choose only to put the really important stuff in here, like the secret. Completely your choice. Again, I'm showing you the full step here, how I do it. You can choose to do this any way you see fit once you understand how this all works. So let's pop in the object ID, and let's get that ID there and pop that in. And the final one will be our secret, and the most important one. And hopefully I've blurred these all out before I publish the video. That's out there. Now for the secret, we obviously set that to expire in a year. So that would be probably quite a good one just to add in quickly. So that's saying 2022. That's actually wrong. So that's saying 2021. And let's set it for that then. And let's just set it for, say, I don't know, 1 minute past in the morning. There you go, 12:01 a.m. And that's it. So we can query this and we can get alerts based on when that is going to expire. And let's hit create. And great. All right. So we've got 6 things in our Key Vault as secrets, and we've got one with an expiration date because we know when that is. And they're all in there, and we're going to come back to these later. The final thing we need to do is, remember what I said when we created this Key Vault, is amend the access policy to ensure our service principal has access over to see the keys. So if you click on access policies, you'll see that my account who created this has got permission to see the keys and add keys. We actually need to add an access policy. And we're not going to use a template. We're just going to go into secret permissions and hit get and list. So we're just going to say that the only thing that the service principal that we're going to use from Azure DevOps, the only thing you can do is get and list our secrets. And so we can select there and select our principal. And if we look for TF ASDO SPN, we can add that in there. And then we can click add. Now the most important thing to do that a lot of people forget is to click save up here. Otherwise you'll click away and it won't actually take effect. So we can click save. And that's it. So that's it for setting up the service principal. We've got one more thing to do inside of Azure DevOps, which is create a variable group, which is going to link the Azure DevOps variable group to the Azure Key Vault that we've got here based on that service principal we've just connected. So it's going to use that to talk to the Key Vault and create a variable group, which we can then use in our pipelines later. So if we go back into Azure DevOps, and if we go over to the left-hand side and click under the rocket and then library, we can click on there and click on that. And this is what we want. We want a variable group. So let's create a variable group. Now I call this the same as my key vault, just so that I know what it is. So let's go and get the name of that key vault in that case. I'll keep all the naming consistent just so that it makes it easier for me to work out what's going on. Now we're going to allow all of our pipelines to access this, and the important select or radio slider here is this link secrets from Azure Key Vault as variables. So it means we're not actually going to put anything in the variable group here. We're actually going to go and get them from the key vault, and therefore we know it's secure because we can control the access policies on that key vault. So we can select there. Now it's going to ask us, well, where is it? So if we click this drop down, now because we created that service connection earlier, we should get a drop down of here of our service connection to use. And we do. So our available service connections here is this TF ASDO demo SPM one that we created. And now that's going to let it actually query the Azure APIs, and it's found the one that it's got access to. If you haven't done the permission granting, it's not going to be able to see this. So we can select that key vault because we've done all of that. And now we can click add variables, and now it's going to query that key vault. And here you can see all of these secrets here actually match the secrets that we've got within inside of our key vault. So it's queried these and brought it out, and it's even brought across the expiration date as well, as you can see for one of these. So we want all of these, so check all of them so that Azure DevOps knows about how to get these, and we can click OK. And that's it, hit save. So now we've got a variable group that we can use in our pipelines later that automatically links to our key vault. So Azure DevOps doesn't have the secrets, it has to go to the key vault. So you've got one place to store and manage all of those secrets and keys. If you change it, it's over there. This part in Azure DevOps, the variable group purely links Azure DevOps to that key vault so that our pipelines can use that. Okay, right, that's this section. I'll stop here and we'll get into the next step in a second. Okay, so in this step, we just need to set up some prerequisites for Terraform, as in we need to put some Terraform code. So we need to put a providers file together and a provider block together to tell it we're using Azure RM provider from Terraform's perspective. And we also need to configure the backend to make sure it's going to use that storage account. Even though we won't be able to test it works, because we're not going to specify the key, we're just going to put those files into our Git repo and commit that up to our Azure DevOps repo inside of our project to make sure that the code's there so that when our pipelines run, they can see that code. So we need to go into VS Code. And then first thing we need to do is create a folder, because I like to put all of my Terraform code inside of a folder inside the repo, just in case the git ignore file, we want that in the root, leave that there. And you want to put anything else, any other structure in here, you haven't got to move stuff around or change any pipelines. Start from the beginning by putting everything in, all your Terraform configuration files in a folder. So let's just call it Terraform. Great, and inside this folder we're going to create a new file, and let's call this providers.tf. Okay, so first thing we need to do is specify what provider we're going to use. So in true Blue Peter fashion, I'm just going to copy one from here I had earlier. So I'll just zoom in as well to make that a little bit bigger. So we've got here, we're going to say the provider is Azure RM. The version, actually, let's change that to use the latest version, because that's saying anything equal to or later than that version there. I think it's equals, and let's use the latest version. I think that's 22.37.0. You can check that on the Terraform Azure RM docs provider page, and it'll always show you the latest version at the top. Put our features block in here. And I always specify the subscription ID to make sure that this is using that subscription. So this subscription is actually the subscription ID, even though you can't see it because we blurred out. This is the subscription ID of the management subscription I have, where we've created that storage account in the key vault and all those things. And obviously the service principal has got access over. So that's there. The other file we're going to need to create is a backend file. And most importantly, make sure you save your file. So we'll save that. Let's create another file, and let's call this backend.tf. And again, I'm just going to go and copy this out, and we can then amend the values. So we're saying the backend is Azure RM again. Now we're going to need to put in the name of our storage account, and let's go and grab that. So let's just go into our resource group, into our demo, into our storage account. So we need that. Let's pop that in there. We also need the container name, which was just Terraform state. And key. Now this isn't the key to access the storage account. Key is actually just referring to the name of the tf state file it's going to create. So let's rename this to tf asdo demo.tf state, and that's just going to be the name of the file. Now there are some missing properties out of here on purpose, being the main one there, the access key to get into that storage account, but we don't want to store that in our code. We don't want to commit that to our repo that everybody could potentially see. So we've put that in our key vault, and I'll show you later on how we're going to get that and run that at the build pipeline time to make sure that it's not stored in our code, it's injected at runtime, and nobody ever knows what that is. So again, save that. That's all complete. And then the other file we're going to need to create, you may have saw on our providers file, we've got these variables here saying we're going to take these as inputs, because obviously, again, we don't want our client ID, our client secret, and our tenant ID stored in our code either. That's again in our key vault that we're going to use as part of the pipelines to inject when they run. So the next file we're going to create is, we can just call this variables.tf. And again, in a Blue Peter fashion, I will copy ones I made earlier. So I've created a variable for SPN client ID, the client secret, and the tenant ID, which matches up to these SP variable names here. And again, let's save those. And once they're all saved, we just need to commit these up to our repo to make sure that they're in the Azure DevOps repo and they're not just sitting locally on our own cloned version of the Git repo. So we're going to stage those changes by clicking add, and then we're going to say tf initial files and click commit. Now that doesn't actually put them up to Azure DevOps, it's just committed them to our Git repo locally here on my machine. So down at the bottom you'll see that I've got this sync icon and a 0 saying there's nothing to download, but I'm actually one ahead, so I need to push something up to my repo. So if I click that button there, that will sync it with my repo in Azure DevOps. And once that stops syncing, we can go back into Azure DevOps, and if we go to our repos and files, and there we go. We've literally just now we've created this. We go into here, we can look at Terraform Backend, Terraform Providers, and it looks like I didn't create the variables file because it's not showing here, or if I did create it, I put it in the wrong location. So let's just double check that. So let's go into here, and yeah, absolutely, I put it in the root of the directory, not in the Terraform folder. So if we go back here, look, it's sitting in the wrong place. So let's go back on my machine, and let's just literally drag and drop that into the right folder and move it. Now that's going to show us a couple of changes in Git, because technically it's a delete and an add back into the right place. So we can stage both of those changes again, and we can say fix var file location and hit commit, and again push those changes. And if we wait for that to finish and go back into Azure DevOps and do a refresh, we go into our Terraform folder. As you can see, they're now all in the right place. We've got our variables file, our providers file, and our backend file. So all looking good, everything's in the right place, and we've got these 3 files set up ready to start building our pipelines, which we'll get onto in the next section. Okay, so we've initialized Azure DevOps. We've created some prereqs for in terms of the storage account for the remote backend, the key vault. We've set up the service connection in Azure DevOps. We've also set up the Terraform files to be ready so that we can inject those key vault secrets at runtime. We now need to get on to actually building some pipelines, right? So the bits that you've probably all been waiting for. So back into Azure DevOps, and then we need to click on the rocket and the pipelines on the left, and click on pipelines. Now I am going to create these in the classic way. So yes, we could create these in the YAML format, but I really want you to get hands-on and understand exactly what's happening at each step without having to learn YAML pipelines at the same time. So yes, you could do this all in YAML pipelines, and if you can, fantastic, great. But for this example, I'm going to use the classic pipelines just so you get a really hands-on experience of how to do this. So we're going to click Create Pipeline. And then really importantly, when this loads up, don't select any of these options here. We need to click Use the Classic Editor down here. So once we click Use the Classic Editor, we'll get a different prompt, and now we can start using the options. So it's going to say, where's our source code stored? Well, it's actually in Azure Repos Kit. It's inside of this project, and it's actually this repository. And we want to use this branch, right? So this is the branch we want to use, our main branch. Hit Continue, and then again we want to start with an empty job. So let's just hit Empty Job. And great, this is our main editing window for our build pipeline. So the first pipeline we're going to create is our Terraform plan pipeline, right? So the one that when somebody approves a pull request, the first thing we need to do is a plan and make sure that what are they going to do, and is it, are we approving of what they want to do? So it's creating that plan file, doing the Terraform plan action, and spitting out a plan file. So let's rename our build pipeline to Terraform plan. And then what we also need to do here is say where our agent pool is. Now I'm going to use the Azure hosted agents because I don't have any of my own private self-hosted agents. So we're going to say the Azure pipelines. And I'm also going to select from the list to use Ubuntu 18.04. This is just personal preference. You could use Windows. I just like using Linux because I find it a lot faster for these sort of actions. Cool. So now if we click on the agent job 1 over here, we're just going to rename this agent job again to Terraform plan, like that. And then we're going to say use the agent pool from the pipeline, which we set back up here to Ubuntu. So back onto here, and we now need to add a job. So if we click, or add a task, sorry, to this job. So if we click on this add symbol here, and we've got all of these options here. Now we actually need to, the first thing we need to do is install Terraform. Now it is actually installed on the hosted agents automatically, but we just need to make sure it's the right version that we need, right? You might be using a different version of Terraform to the one that we've already pre-installed, so it never hurts to make sure that the right version is installed. So if you look for Terraform tool installer, you'll narrow this down to one list, and you'll see it's from us. So it's the Microsoft Corporation marketplace item for this. And we can click add. Now great, that's been added. Now I've already approved this from the marketplace and added it to my DevOps organization. If you haven't, you might have an option on that pane there to select get, and it will take you to another window where basically takes you to the Azure DevOps marketplace, shows you the same extension and says, do you want to get this for free? You hit install, and you would say you choose the organization that you want to link it to, which in our case would be, in this example, the JCC MSFT or DevOps organization, and you'd say what one it goes into, and then it can be used by all of your projects within inside that organization. So that's already done for me, so I've got that here, and we want to install the right version. So the latest version of Terraform is 13.5. And as you can see, it will change the display name up here for me. So let's say we want Terraform version 13.5 to be installed. So that's our first step. And these all work procedurally. So it's in order of the list, and we can drag these around in a second. But do it as you would want it to run step by step. Now the second step we actually need to do is do a Terraform init. So let's get a command line option here. Now there are pre-built Terraform marketplace extensions that let you do this, but I find that doing it yourself gives you a really good understanding of what's actually happening behind the scenes, and you remain in full control. So select this command line option here, and again it's from the Microsoft Corporation, and this may say get, and if it does say get, click get, come in here and then hit refresh. You'll be able to add it back in once you've gone through that install process. But it's already added to my organization, so I can click add. And it's got a command line script here. So this is going to do our Terraform init. So let's give it that name so it's very obvious on what's going on. And this is where we put our script. So I will just grab one that I had earlier, and we can replace the bits that we need to replace. So as you can see here, it's saying Terraform init, which command you should all be comfortable with. And then we're passing in this backend config. Now, if you remember, inside of our DevOps, inside of VS Code, inside of our backend file, we had the storage account name, the container name, and the key, but we didn't actually specify the access key, as in what's the secret to get in and do stuff and put files in there or read the files into that storage account. So to do that, we are actually injecting effectively another line into this backend block with this command hyphen backend config and then equals access key. Now, as you can see, I've wrapped this in speech marks, and then I've got a $sign and then another brackets. Now, this actually means go and get another value. It's an interpolation syntax, right? So it's actually going to go and get this from a variable, and we're going to link this up to our variable group at the end. But what we're going to do is we need this to be matched the key vault secret name that stores the access key. So if we go back into our key vault in Azure, and let's just go back to our resource group, into our key vault, and into our secrets, we've got this one here. So let's use key 1 for this, just in case we want to roll it over. We've got key 2 there in case we need to change this at a later stage very easily. So let's grab that, and let's pop this inside of those brackets here. So we're saying that the access key is actually stored in a variable, and at runtime it will go and get that from the key vault via the variable group that we set up earlier and inject that into this string instead. So that's one thing here. One thing we need to do as well is that all of our Terraform files are actually stored inside of that Terraform folder inside our repository. So we just need to tell that this command needs to run inside of there. Otherwise Terraform will look and say, well, there's no files in here. What do I do? So if we click on that and we click on our Terraform folder, and we just click OK on top of the Terraform folder, and that means it will run this command within the context of that Terraform folder inside of our repo. So that's great. It's now going to initialize, get access to our backend, all good. First step done, download providers, all of those sort of things. The next step, we want to do a Terraform validate. Just make sure that it's all syntactically correct. So let's clone this task. So you can right click on the task here and click clone, and that will keep all these properties the same and just saves you a bit of typing. So let's change this one to Terraform validate. And the command we need here is very, very simple. It is literally Terraform validate. So that is the only command we need there. And again, just check under advanced that our working directory is still that Terraform folder inside of our repository. We then want to clone the task again, because then now we need to do the actual Terraform plan. So let's rename this to Terraform plan, and let me go and get again the Terraform plan command that we need to use. So quite a long command, but let's break it down step by step. So Terraform plan, a command that we're all used to. So do that plan stage, tell me what you're going to do. Hyphen input false, so don't prompt me for any input variables at runtime. And obviously, because this is running in a hosted container, we're not going to be able to type anything in. So we need to make sure that this is actually happening. This doesn't happen. We don't get any prompts to put in input variables. So if they don't exist or they're required, it will just ignore them and carry on with null values. Hyphen out equals TF plan. So we're saying output the TF plan, so the Terraform plan, to a file that we can use later, so that we can save what was going to happen in this Terraform plan action and use it later. So out into a file called TF plan, and then we're injecting a load of variables. So var SPN client ID, var SPN client secret, var SPN tenant ID. Now you might think we created these earlier and put them in the key vault, and that's absolutely correct. And if we also go into our Terraform configuration in our providers file, these are all these variables here, right? So we're specifying these values because obviously they are just variables at this stage. We need to put this to real values, but we don't want to put them in the code. We want Azure DevOps to inject them when this pipeline runs. So we put these all in our key vault. So again, what we need to do is change the values in the brackets. So the first one we need is the client ID. So let's go and get the client ID from my name of the secret inside my key vault. And that's the one we need there. And change the respective one inside the brackets. And there we go. Make sure we've got no spaces around it. The second one we need is the secret. And instead of going there, because we put in a good naming scheme for our secrets, this will be very easy for us. So we can replace that there with secret. And this one here, we can swap out as well and change that to tenant. Okay, so that's everything there. And then under advanced, just make sure we're in that Terraform folder again. Right, and now we need to add an archive action. So we've done all the Terraform actions. The Terraform plan has happened. It's output a file called TF plan, and now we want to capture that TF plan and all the files into a zip folder and then publish that to an Azure DevOps pipeline artifact so that our release pipeline can go and get that and run it and extract it and make sure it's only happening against those files and not any new ones that have happened in the repo since. So we need to add another action. So click on add here. And we need to add this one that's called archive. And as you can see, we've got archive files. And again, it's from the Microsoft Corporation and you might need to do that install process. We can click add. And let's put it in here. So I call mine archive Terraform plan files. So let's just rename that here. And we now need to put in the folder that we want to basically zip up. So that's our Terraform folder in here. So if we click on here, it's going to be in this folder because that's where we run those other commands above from. So we can click on OK. And then we need to change the archive type. So because it's running Linux, let's use tar and gz compression. And then what we need to do is just specify the file that we're going to call this zip folder this tar gz file to be called. So let's just paste that in there. Make sure we've got no spaces. And these variables are automatically built into Azure DevOps. So it's saying the build artifact staging directory and then create this file here. So that's fine. You can look at these all up in the documentation. There's lots of them in terms of there's some pre-built defined variables that you can use. And that's fine. We can leave that there. We can leave these checkboxes as they are. And that's that one. And then we need to add another action, which is publish Terraform plan, publish the Terraform artifact that we just created. So we go publish and publish pipeline artifacts, add that one in. And again, this one I'm going to call publish Terraform plan artifact. And the directory for that is going to be the same as the archive here. So it's where we're creating this archive here. That is exactly the same as the directory that we want to publish. So we're linking those together. And we're going to give our artifact name just the build ID. So the build ID is the run number for this build pipeline. So that will change every time it runs. It will just go incrementally up. And then -tf plan. And we want to publish that to Azure Pipelines. And that's it. So that is it for this one. So there's a couple more steps that we just need to do. So click under the Variables tab. And then go under Variable Groups. And what we can do here is link variable group. And here's the variable group that we created earlier. That's linked to our Key Vault. And we can click Link. And that will give this pipeline access to that variable group. And therefore access to the Key Vault. Using that service principal we created earlier. And if we drop that down, you'll see that all the values are here. And it doesn't know them, but it will go and get them at the time of run. And we just need to set our trigger as well. So if we click on Triggers, we need to click Enable Continuous Integration. And that means that when anything changes in the main branch, run this pipeline. We're going to protect that with a branch policy to make sure it happens via a pull request. Also, we're just going to actually add in here that it only happens on files that change in the Terraform directory. Because if it happens outside this directory, it's not related to Terraform and therefore we don't care about it. Okay, so that's that. So we can hit save. Don't hit save and queue. There's no point. We don't need to run it right now. We can just hit save. And you could select a folder if you've got different folders for your build pipelines, but we can just say the default root directory and hit save. And that's it. That's saved. So if you now click on pipelines again on the left, you'll have Terraform plan here, and it's got no runs. If you ever want to go back in here and edit it, you can click on the ellipses here and click edit, or you can click on the actual pipeline itself and click edit up here. Now, because I've clicked into that pipeline, we actually want to clone this for our status check stage. So if we click on there and click clone, it's going to clone this pipeline. And our status check is the one that runs whenever we create a pull request, just to check the code's syntactically correct and the reviewer can check what it's doing. Now, we can just rename a few bits in here. So if we call this Terraform status check, and I'm just going to put in brackets what it does. So it's a validate and plan with no out file. And we want to use all the same options, and I'm just going to copy that name and put it here as well. And then we just need to delete a few things in here. So we still want to install Terraform. We still need to do the Terraform initialization. We still need to do the validate, and we still want to do the plan. However, we don't need to put the out file in here, so we can take that out. We still need to pass in those variables, and we don't need to do these archive steps. So we can remove that task, and we can remove the publish artifact task as well, because we don't need that. We just want it to run and give us the outputs. Check that it's still running inside of our Terraform folder, and then we still need to make sure it's got access to our variable group, which it has. If it hasn't, relink that, and we need to go into triggers, and we actually need to disable the continuous integration trigger for this pipeline run, because we don't want this to run every time new code's committed. We've got our Terraform plan pipeline to do that. This one should only run when our pull requests are created, and we'll get onto how to configure that later. So again, hit save, leave it in the root folder, and just hit save. So now if you go back to pipelines, we should have 2 pipelines in here with no runs. And that's it. We've created our first build pipelines that are going to do the Terraform plan stages, and we'll get on in the next section on our release pipeline, and which will do the actual deployment on there and how we can control the approval gates and all those sort of things. So catch you in the next section. Okay, so we finished creating our Terraform build pipelines for our Terraform plan states and our Terraform status check that we're going to use with our pull requests. So now we just need to finish creating another pipeline in our release section. So back into Azure DevOps again, under the pipeline section, we have releases. So let's click on releases. And again, we're doing this the classic way. We could do all of this inside of a YAML pipeline, but again, we're going to do this the old school way so that you understand truly what's happening at each step of the process. So we've clicked on releases and we've got no release pipeline, so let's create a new one. And when we create that new pipeline, it's going to pop up here with, again, all of these options. Let's just select empty job. And we need to give the stage a name. So I call mine Terraform apply. And I can be the owner of this stage, and you can just click away or click the little close button here to move that away. Now what we also need to do here is link up the artifacts. So at the end of the Terraform plan stage, we export that artifact, and we need to make sure that we're using this to trigger this pipeline. So if we click on our add an artifact, and it's from our build artifact in this project, and if we drop down this source, we'll see that we've got our 2 build pipelines here. So let's just select our Terraform plan one, because that's the one that exports an artifact. And as you can see, it spits out all of this here, and we can leave all of these options as default and click add. And then what we can do here is click on the little lightning bolt in the top right hand corner of that Terraform plan artifact, and we can enable the continuous deployment trigger. So we can say that every time that there's a new build available, you can kick off this pipeline. And obviously we're only going to allow this to be triggered because the Terraform plan build action will only ever trigger once code is pushed or merged into the master or main branch, and that's going to be protected by a branch policy, and we're going to enforce that with pull requests to make sure that everything's reviewed and approved before it actually happens. So we can enable that CI/CD trigger there, and that's all we need to do there. We can hit the little red cross in the top right hand corner, and then we need to actually configure the steps of our job. So if we click on the little blue where 1 job 0 tasks link beneath our Terraform apply section, we can click into this, and it looks very similar to the previous build pipeline creation steps. So we're going to do very similar things again. So we're going to change our agent job to run on Ubuntu 18.04. We're going to change the name of the agent job to Terraform apply, and then we're going to add some tasks in again. This time we're going to add an extract files task first. So when we've got that, it pulls that artifact in automatically as part of this pipeline because it's used as the trigger, and then we need to extract it because it's in a tar.gz format as it stands. So the command we're going to need to pop in here, or the file pattern, is as per the screen. that I've just pasted in. So this is the alias of the artifact that was configured when we linked the artifact on this release pipeline, and then this will look very similar to what we put in at the previous stages when we created the build pipeline for Terraform plan. So pop that there, and these will all be linked to in the blog post that complements this video, so don't worry about taking a note of all these will all be available for you. And then the destination folder, we just need to dump it to the default working directory of the hosted agent, so we can select that there. And again, I'll put all these in the blog post. And we need to uncheck this clean destination folder before extracting. So there's nothing in there already, so we don't need to clean it. It just slows it down. And that's it. We then need to go get into the Terraform install process, so we can look for our trusty Terraform tool installer again. And there we've got it, and we can click add. And again, we want to make sure that these versions match, so 13.5 was the one we used before. And then we need to add a command line task. So we look for that in the marketplace and click add. And this is going to be Terraform init. And it's going to be the same commands that we use in the build and the status check pipeline. So let me just go and grab those. And actually, if I open up a new tab, I can go into one of our other pipelines and go and get the commands to save me having to change them. So click on Terraform init, copy the script, and then back into our release pipeline and pop that in there. We're also going to need to make sure we're running this in the right folder. This time it's a little bit of a different path. So we're extracting the files to the system default working directory variable. We need to just make sure it's going in there and then inside the Terraform folder that's contained within that zip file. So we can paste that in there. So inside our default working directory and then the Terraform folder within there. And then we need to add another action for Terraform apply. So we can copy as we did before, select Terraform apply in there, and then all we need to do here is add in the parameters for the command here. So Terraform apply -auto -approve, which means if you run Terraform apply normally on your machine, it actually does a Terraform plan first, and then it will say, this is what I'm going to do, this is what I'm going to change, this is what I'm going to delete, this is what I'm going to add. Do you want to do this? And you type yes. Obviously, because it's running in a hosted agent, as discussed before, we can't do that. So putting in this parameter, -auto -approve, stops it prompting for yes. It'll automatically approve it and go to the next step. And then we also need -input equals false. As we discussed before, we don't want any equals there. Let's make sure we put equals to make sure that no input parameters that are required are waited for and prompted for at the terminal, because we won't be able to put them in. And then we need to put tf plan. Now that's the tf plan file that we export during the Terraform build or the Terraform plan build pipeline. That's the artifact that's exported, and we're saying we want to commit, or we want to do an apply based on what was in that plan file. So not what's in the repo now, because that may have changed. We want to do it based on what was in that plan file at that time, because we can ensure consistency throughout the approval process, and we never get into that stage where you may approve a release pipeline to run, it goes and gets the latest code from the repo, and that might be different to what was initially approved in the pull request. So by making sure we're putting the Terraform plan from the build pipeline out as a file, we can ensure that that file is kept all the way throughout this process consistently, and it's only ever that what's in that plan file is committed and applied to the environment. And again, we just need to make sure that's going into the same directory, and that's it for our apply stage. Now, actually, we need to link our variable group again, so we can go into variable groups, and we can click link variable group, add that one in for our key vault again, and hit link. And if we drop that down, we can see we've got all of our variables in there again. They can be used when we're the tasks query for them, so they'll be swapped out. And that, I think, is pretty much it, apart from our approval gates. So at the moment, this will just automatically run and won't ask for approval. Now, to add that second step of approval before it deploys, if we add an approval gate, so if we click on the lightning bolt on the person on the left-hand side of the Terraform apply stage, we can say, actually, there's a pre-deployment approval required. We can select that to enabled, and we can put in the people that we want in here. So let's put myself in, for example. And we can set how long this approval can wait. So let's say it can wait for 7 days, and after that, it can disappear and it will just be denied. And we can also set some other options here, like the user requesting a release or deployment can't approve it. Now, obviously, I would select that in a best practice world because there should be multiple people in the environment. But in my world, I need to leave that unchecked because I'm the only person in this environment. We can select revalidate the identity of the approver, so force MFA tokens if they're configured and all those sort of things to happen. And also we can select this option here that says skip the approval if the same approver approved the previous stage. That's not relevant in this environment. So we can select that there, and that will basically, when this pipeline runs, when it gets to the Terraform apply stage, it will trigger another approval, and until that approval is granted, the steps that actually commit the Terraform apply changes to your Azure environment won't take place. So that's all good there. And we can just rename this pipeline as well to Terraform apply. And that is it. So we can hit save. And again, leave it in the root folder. Okay, all right, so we've got all of the pieces now falling together. So we've got one final section, and that's to talk about our branch policies. So I'll catch you in the next section. Okay, so we're at our last stage. Now we're going to enable a branch policy to ensure that the code going into our main or master branch is only coming via a pull request and can't be directly committed from a merge or a push from any of your Git clients. So to enable that, we need to go onto our repos and select branches. Then for our default branch, and this could be any name, but mine is main in this example, yours may be master, but you can call this whatever you like when you create your repository. So make sure it's the default one. And if you go right over to the right hand side and click on the three dots and click branch policies, and when this loads, you'll see we've got a number of options to enable here for the main branch. So the first one we need to enable is require a minimum number of reviewers. So you should leave this at 2 or more, depending on how many people are in your environment. But as I'm the only person in this environment, in this demo, I'm going to set that to 1, because there are not 2 people who could manually approve this. I also need to select this allow requesters to approve their own changes, because I am the only person in this environment. I would suggest leaving that unchecked in most scenarios. I also need to want to select when new changes are pushed, reset all code reviewer votes. So that means if we got a current pull request in place, and somebody puts submits the pull request based on a certain commit of their branch, and then they suddenly add another thing into that pull request via pushing code into the same branch again, we want that completely re-reviewed, because that may be completely changing what's getting deployed into Azure via Terraform. So I'm going to reset all the reviewer votes, and they have to vote again. Then we can limit merge types. Now, this is personally just a personal preference. I only allow squash merges so that we only get 1 commit per pull request going back into the main branch to keep things tidy. But use whatever your personal preference is there. And then under this build validation step, what we want to do is add one here. So we can add a new build policy. And if we drop down our build pipelines, we've got a Terraform status check, which is the one we want, because we don't want the file to be created out of it, but we still want to see if the Terraform code is valid, and also what that code is going to deploy, so we can review it in the PR stage. And we're also going to put in a path filter here, and we're just going to put in here star.tf, because that's all the Terraform configuration files will be using as a file extension. So we're going to set that there. And we're going to set the build expiration on here to be immediately when main is updated. And we're going to just set a display name check here, or a display name to Terraform status check. And then we just put in here the same as what it's called. So validate and plan no out file. And just quickly to make you understand why we're saying the build expiration immediately when main is updated, if main is updated, there might be multiple pull requests going on in your environment, and if somebody submits one and it goes through and gets committed to main, that's going to change effectively what your code is going to deploy. So we need to basically scrap that and do another build and see how that your current code changes would impact what's in the main branch. So it's best practice to do that in this sort of scenario. So we're going to hit save there. And one final thing that you can choose to do as well is this bottom piece, so automatically included reviewers. So instead of you having to specify every time when you create a pull request, you can set a policy effectively saying these are the people that I absolutely always want to review my pull requests, and without having to specify them every time. So I'm just going to add myself in here and say I'm a required reprover, and we can say requesters can approve their own changes as well. And let's hit save. Okay, so that's it. There's no save button on this option. It's literally just enable the sliders and it's on. To test that, if we went back to our main repository, now instead of going into VS Code and committing something and pushing it up, we can do exactly the same here. So if I just go into the git ignore file, for example, and do an edit, and let's just add test comment. I shouldn't be able to commit this because it's not gone through a pull request based on the branch policy. So if I hit commit and say update git ignore and hit commit, I get an error message saying push to this branch and not permitted. You must use a pull request to update this branch. And that's because we've put that branch policy in place. And that would work exactly the same if I was using VS Code or Visual Studio on my machine to push that git change back up. It wouldn't be allowed, it would deny, because it's not being done via a pull request. So I'd need to create another branch, put my commits into that other branch, and then create a pull request to put it into the main or master branch. Okay, so that's everything done here. The next step is giving it a go. So I'll catch you in a second and we'll give it a go and hope it all works. Okay, so let's test out all of those things that we've put in place in Azure DevOps and make sure it works. So first off, let's create a new branch inside of VS Code. So click on down here on main and click create new branch, and let's call this test1. And we can see that that's changed now to that branch inside of VS Code, and that means Git has changed to that branch as well. Let's create a new file inside of our Terraform folder, and let's call this main.tf. And let's just create a resource group and see what happens. So resource Azure RM resource underscore group, and let's give it a name. So test RSG 001, and let's say its name is test RSG 001, and its location, if I could spell location, equals North Europe. And that's about it. Let's format this file. So Shift Alt F if you've got the Terraform formatter installed, which I don't in this example, but we know, let's just make sure all of our equals signs are aligned as good practice. And that's it. So save the file, and then you can see on the left hand side we've got something to commit to Git. So let's go in here, and it says main.tf. That's the file it's got updates, so we can stage that. And let's go add test RSG and commit that to our branch, and then push this change to Azure DevOps. So that's pushing now. And if we go back into our Azure environment, first of all, let's just go into our resource groups. And as you can see, we don't have a resource group called test RSG 001. So that doesn't exist at the moment. So we don't see that here in our Azure environment, but hopefully after this process, we will. So let's go back into our Azure DevOps environment and click back on files, and let's just say leave on that option. And you can see we updated test1 branch just now. Do I want to create a pull request? Yeah, so let's create a pull request, and let's just call this test1 create test RSG, and we could put in here testing and then we can say creating test RSG 001. We can leave all these options as blank because we've set up our policy so that I should automatically add it as an approver here, and we can hit create. And there we go. Okay, so we can see a couple of things here. So our Terraform status check, validate and plan is on its way. That's getting run. And you can see I've been added as a reviewer. So let's go and check out this. So if we click on our Terraform status check and go and inspect what's going on in here. So it's installing Terraform. It's doing the initialization. It's done the Terraform init, done the Terraform validate, and it's doing the plan now. It's just checking what to go on. And great, that looks like it's worked. Let's just check what was in the plan. So the plan says we're going to add one resource group called test RSG 001 in North Europe. Fantastic, so that's what we wanted. And the most important part here is if you look at the Terraform plan and input where we've got our commands, remember in our SPN client IDs and these secrets that we were passing in from the Key Vault, you'll see that actually we don't see ever what those passwords or secrets are. We just see ****, and that's because Azure DevOps is aware they're a secret because they came from the Key Vault in the variable group. So you can see one of the very first jobs is it downloads those secrets from our Key Vault using the service principal that it has access with via the service connection we created at the beginning. So as you can see, it's downloaded all these secret values and put them in as environment variables. They only last as long as this hosted agent container is running, and as soon as it finishes, that's it. It gets blown away and created, rebuilt from scratch. So it'll have no knowledge of these again. So let's go back to our pull request. So if we go into repos and pull requests, we'll see that so our required check completed, and if we click view check, that's that status check that's happened. So that's all good. If that had failed, we'd get a red cross and we'd be aware of that. And now it's saying Jack's got to approve it. So, if I was approving this, I'd come into it and look at a few things. I'd first check the files and see what were being changed. So I can see, yeah, it's just one file and it's that here. And then I'd also go back and check that this required check had completed by clicking on there, going into the job, and looking at the Terraform plan stage and just checking the bottom of this file to make sure what was being deployed is what the pull request was stating was being deployed, and it wasn't going to break anything or delete anything that I wasn't aware of. And once I was happy with that, I'd go back and I'd go back again, back to the pull request. And if I'm all good here, I might put some comments if I need anything changing, or I can say, yeah, it looks good to me. And I can say, let's resolve that comment so that doesn't get in our way. And I can say, yeah, approve. And now I can say complete. And based on our policy that we said only the squash commit could be allowed. And as you can see, the rest are forbidden. And I'm just going to customize the merge message here so that we'll just see what it's going to create. And I quite like this. So it's saying merge from pull request 8. Based on the pull request title, and it puts in the description notes here as well. So I'm going to say complete merge, and it's also going to delete that test1 branch from the Azure DevOps repo automatically for me once it completes. So we can say merge there, and as we can see, it's now merging that pull request, so it's putting that code back into main, and that's completed. So now if we go back into our repo and click on files, we'll see that we're in the main branch here, and that's the only branch that now exists because the other one's been deleted because the pull request completed. And we can see that in progress. Now, if we click on that, we can see it's the Terraform plan stage that is running. So our plan build pipeline is running. So let's go and check out what's going on over there. So if we go into that Terraform plan, and as we can see, it's already pretty much all the way through this. So it's done the same thing, downloading the secrets, installed Terraform, done the Terraform plan, and it's adding that same resource. It's done the archive, so creating a zip folder, and it's published that artifact to the pipelines so that it can be used in other jobs. So we'll wait for that to finish. We can see that here and monitor it from here. And as you can see, that's just taken like around 50 seconds. So I wouldn't expect it to take much longer than a minute, 2 minutes. Obviously, that would depend on the size of your Terraform code. The more you have, the more it's going to have to do, but it's pretty quick because we're using the Linux build agents as well. So that's now completed. Now if I go into the releases, you'll see that I've got a pending approval. Now, I'm going to get an email message saying I need to go and do this, go and review this approval. But if I come into this release one that is waiting for me to approve, and I can see it's waiting for my approval because that's what we set on the approval gate. And we can see that it's come from this artifact 28 from the Terraform plan stage. And if I wanted to go and look at that, and if I was reviewing this as a reviewer, I would go, okay, it's come from here. What is this number 28? Let's go and have a look at that. Click into that, and I can see, okay, it came from this build job from pull request 8, and I could now go back and look at pull request 8 if I wanted to. But as it's already been approved, I shouldn't have to worry about that. And I can come in here, look at Terraform plan, and go, okay, we're adding a resource group. That's all fine. And just to prove that resource group still doesn't exist at this stage. And if we went back into here, and we went back and back, and went back onto the other tab for our release pipeline, and we say, okay, it's still waiting for me here. Okay, and I can say, yeah, it looks good to me. Let's do it. I could defer it to a later time if I wanted to, but I won't. I can say approve. So now that's going to go and queue this job to run on one of the hosted agents and hopefully deploy our resource group to Azure in a second. So let's have a look at what's going on here. Let's have a look at the actual job itself. So downloading those secrets again, downloading the artifact, downloading those secrets now, installing Terraform, extracted the files, doing a Terraform init, and now it's doing a Terraform apply. And hopefully, well, there you go, it's finished. Perfect, okie doke. So if I go back into Azure and do a refresh and wait for ARM to update and wake up, we should see my resource group appear in here in a second. Obviously, there is a little bit of a delay sometimes on this portal, so we need to wait. Let's do a full refresh and see if it will appear. And as we can see, the full refresh did the trick, and we've got our test resource group here, and that's been created in North Europe based on the subscription that we linked the provider to in our Terraform code. So all good, that's all worked, all managed from a DevOps pipeline, and now you know how to build that yourself with all the approval matrices. So I hope it's been useful. Leave some notes in the comments, feel free to tweet me, and I'll leave some useful resources on the blog post as well. Thanks for watching.